So now I want to show you something that you can actually play with in order to have a bit more control over how forces are applied to your particles. If you dive inside, you'll see that here, for instance, on the bulb force, you have this option of using VEX expressions to control the force vector, and you also have it here. And this will allow you to kind of play with these parameters based on some expressions. You do have a bunch of presets here, amplitude by age or amplitude by normalized age, and you'll see that this amp doesn't even have it's not an actual attribute or anything. It's just based on the name of the parameter here, amp. And this is a great starting point. So pretty much what this would allow you to do is multiply the current amplitude based on a smooth interpolation between that goes from 0 to 0.2 based on the normalized age. This is an attribute that is something that's already reserved. So pretty much what this gives you is based on the age of the particle, based on the life of the particle, it divides the age by the life and it gives you a normalized age value that goes from 0 to 1, being that 0 is when the particle is born and 1 is when the particle is going to die. So this will give you an interpolation between these two multipliers of the current amplitude. So we would expect that in this situation, the pulp force, the noise will have a lot more effect as the particle approximates its own death than in the beginning of its life. Okay, that's pretty much it. I don't think we'll be able to distinguish it that much. Maybe we would have to go a bit more extreme on the amplitude to actually be able to see the difference. So this is what we have with the VEX expression. And this is what we have without the VEX expression. So I can't really notice much on this, but we can actually use the same principle. Let me put this back to the value we had before, 0.5, and I'm just going to grab this, Control C. I'm not going to use the VEX expression here. I think it's more interesting to have it on the drag. So what I'm thinking is we can have the drag actually be much stronger to the particles that are furthest away from the actual core than in the beginning. In the beginning, it may not be all that relevant, but at the end, it should be pretty strong. So we can use the VEX expressions here. You also have a bunch of in this case, just one preset. But I'm not going to use any of this. I'm just going to use the air resist, and I'm going to apply the expression that we had before. And the difference is that I actually want this to be applied from 0 to, so I'm going to increase the air resistance to maybe something like 40. And then the next step is going to be for us to kind of go from 0 to 0.5. So in the beginning, we won't have much drag being applied to it, but in the end or closest to the end, we should have a lot more. And it gives us something like this. Maybe, I think in this case, you can clearly see the effect that we're getting. And if I don't use the VEX expression, it's just applying it overall. From the beginning, it starts applying the drag. But if I do this, I can let it expand a bit more, but I would have a lot of motion closer to the core, and as it gets away, it kind of slows down. This will also obviously reflect on our particles color based on what we are doing outside the dot network, because they're going to slow down faster. We should expect to see more of the reddish elements closer to the core, and then they slow down too much to have that red color, which corresponds to the maximum speed that we have. You can also play with the max speed. That this will give you kind of different results. So in this case, we have less of that maximum speed. But again, if I go to 0.1, we get a lot of chaos because a lot of things are going beyond that. Um, Whenever you're doing something that's supposed to be normalized, it's also a good idea to kind of just make sure you clamp this between 0 and 1. That way you know you're not going to be getting values that go beyond the normalized range. So that's probably a good idea. It shouldn't change much on what we have. I don't think we actually have um, that many weird values, but I think it made a difference and it's looking good now. This is something that we can change real time as well. 0.25, play like this. Totally different look. Just playing with the maximum speed. You can see that if I go too high, I don't get any red at all. So something like this, I think 0.25 maybe, 0.3. Yeah, I think this is an interesting look. Okay, so let's go with this. And since we're going with this, the next step is going to be for how we can actually visualize this a bit better. Because as you can understand, looking at this, these are just pixels. We don't have any notion of the three-dimensionality of this. So it is kind of interesting for us to start thinking about that. It is going a bit beyond the limits, but once the artifact actually expands, I don't think that'll be an issue. And we're only going to be seeing it, the core, when the artifact expands. It's probably expanding too much. So here, I'm going to put this down. These are connected. So here. Am I multiplying? Yeah, I'm multiplying by 0.5. Let's go with 0.25. So it doesn't expand that much. I think this will be okay. Let's put in a camera. I'm gonna put a camera somewhere. Doesn't matter. I'm just gonna make sure it's kind of 0, 0, and here 1.2. And no rotation. Let's look through the camera. Let's give it a bit of a wider lens, 35 millimeters. Probably still a bit too big. Can play with the core size as well. Maybe the sphere could come down to 0.3. Let's see how this goes with our actual artifact. Yeah, I think this is a cool look.